Hello, happy people. This is Mr. Wilcox coming to you again from my kitchen table. This would be our second virtual lesson for our chapter on sequence and series for Algebra 2. Yesterday we talked about sequences and finding the next two terms and having them either be arithmetic or geometric. Today we're just going to talk about summation sum for series, and we'll get into arithmetic and geometric series later this chapter. So a series is explained right here. I'm going to pause for a second so you can pause the video and write this down, and then I will talk to you more about what a series is. So a series is like a sequence, only instead of commas in between each term, we have addition signs. So we can find the sum of a series. So again, just like we had finite sequences and infinite sequences, we have finite series that just end, and we have infinite series that go on forever. We're going to start with some finite series today, and we're going to use what's called summation notation. So here's what summation notation looks like. So again, I'm going to pause for a second so you can write this in your notebook, and you can pause the video and start it again when you're ready. All right, so summation notation uses this Greek letter sigma. It kind of looks like a weird E. So below, they'll always give the number that is called the index. So K here is our index. That's our starting number for our terms. And then the top number tells you how many terms you're going to go to. So the upper limit, and so of this is 4. And then the 2K is the rule to find our terms. So today we are going to find our terms, and then this Greek letter sigma means to add them up. So we're going to add up all our terms. So here are the steps we're going to use today. We're not actually going to do this example. We're going to do 3 examples like it, but I did want you to have a picture of what we're looking at. So again, I'm going to pause so you can pause the video, write this down, and then play the video again. All right, so what we're going to do today is we're going to find the sum of a series that is already in summation notation. So we're going to start with the index. So remember, that's our number on the bottom, our K. We're going to plug that in to find our first term. And depending what our index is, here it's 1. So we would plug in 1, 2, 3, 4, and 5. And then we would stop because 5 is our max there. So we would plug in all the numbers between 1 and 5 into our K, and then we're going to add them all up. So we're going to do an example here in a second, so this makes a bit more sense. So this example we are going to do together. So our index is 1, and our max there is 4. So we're going to plug in all the numbers between 1 and 4 into our rule to get our terms, and then we're going to add all our terms together. So we are going to start with 1. So we're going to plug in 1 into our function. So we're going to get 2 times 1, which is 2. And we're going to plug in 2. 2 times 2 is 4. And we'll plug in 3. 2 times 3 is 6. And we're going to plug in 4. And we're going to get 8. So we're going to stop there because we plugged in the numbers 1, 2, 3, and 4. So the bottom number 1 is plugged in. Top number 4 is plugged in, so we can stop. And so then we're going to take 2 plus 4 plus 6 plus 8. And if we add up those numbers together, we get 20. So the answer, the sum of our series here is 20. All right, our second example, our index is 3, and we're going to go to the 8th term, and we're going to add them all up. So we're going to start with the 3rd term and go to the 8th term and add them all up. So we're going to start with our index, which is 3, and plug that in for K. So I'm going to get 4 plus 3. 4 plus 3 is 7. And I'm going to take the next term, 4 plus 4, which is 8. And then 4 plus 5, which is 9. And then 4 plus 6 is 10. 4 plus 7 is 11. And 4 plus 8, oops, I wrote the number 7. It's supposed to be 4 plus 8 is 12. So then we have to add all our numbers up together, our terms up together. So 7 plus 8 plus 9 plus 10 plus 11 plus 12. And if we add them all up, we get a grand total of 70. So the sum for our finite series here is 70. So the third to eighth terms of this series add up to 70. All right, third and final example. We have an index of 3 again. So we're going to start at 3, not 1. And we're going to go to the fifth term. So we're going to plug in the numbers 3 and then 4. And then we're going to stop at 5 because 5 is our max there. So if we plug in 3, we'll get 3 times 3 squared minus 7. And if we figure that out, that is 20. We're going to plug in 4. So we're going to get 3 times 4 squared minus 7. So that's 16 times 3 is 48. 48 minus 7 is 41. And we're going to plug in 5. So 3 times 5 squared minus 7. 5 squared is 25 times 3 is 75. 75 minus 7 is 68. And so if we take 20 plus 41 plus 68, we get our sum, and our sum then is 129. So again, today you just have to start with the bottom number, plug it in, keep plugging in numbers till you get till you've plugged in the top number. So that'll get you your terms, and then you're going to add your terms all together to get the sum of your series. So I hope that's clear. I hope you're happy. I hope you're healthy, and I hope you all have a great day.